I'm okay. We're okay. There was a terrible accident, but we're back to 3D modeling. Sorry for the delay. I've been away. Life has been very busy. Work has been very busy, but we're back to it. Let's make many good 3D models. Today, we are going to make, well, got a little bit damaged. We're going to make this mirror. It's a little bathroom mirror, and it's totally not broken. Pretty good. Pretty good. So we have a 3D model already pre-prepared. Ooh, looking pretty good. We're going to learn how to make this in Autodesk Inventor and then later in Fusion 360. Let's get to it. Okay, we'll start off by having a look at the assembly. This is the finished product. What we can see from the assembly tree is that it's made up of 4 components. We have the base, the mirror frame, and 2 mirror planes. The actual model in real life had one side as like a convex mirror, or concave mirror, and the other side as a flat mirror. Now, one of the advantages to having broken it is that we can actually see on the inside how this actually was, so we can improve this model. It'll be more true than ever. Okay, let's get started. The first part that we're going to model is the mirror frame. So to get started, we'll come to File, and click New, and we'll choose a metric standard millimeter part, and click Create. Now, we'll start off by creating a sketch, and we're going to make it on the XY plane here. And to capture the rectangular shape, we're going to make a center point rectangle. So we'll come to Rectangle, and click Center by 2 points. Click the model origin there, and click on an arbitrary position there. We're going to give it some dimensions. So from measurements earlier, it was 109 millimeters wide and 126 millimeters tall. Beautiful. Next, we'll click Finish Sketch and completely forget how wide it was. So let's measure it. Beautiful. Okay, it's 6.25 millimeters wide. So we'll click Extrude. And here we can choose which way we're extruding it. So in the Z direction, negative Z direction, or symmetrically both. 6.25 millimeters. Wonderful. Going in total in both directions. We'll click OK. And we can see that we made our first feature extrusion one. Let's go ahead and add in the curved sides here. So we'll add in some fillets. We'll come to Fillet. And we'll click the 4 edges, corners. There we go. And they are 25 millimeters in radius. Wonderful. Okay, next we want to capture these little arm doodads on the side. Now, I'm not sure if you can see it on the camera, but it's actually stepped. So we're going to try and capture that with the 3D model. Let's go ahead. We'll make a sketch on the side here. And it's given us a nice center point there. We'll go ahead and make 2 circles. The first one will go the full distance. As we can see, it's not fully constrained. So we'll go ahead and we'll add in a tangential constraint between that circle there and that edge there. We'll go ahead and make another circle. And this one is going to be 6.2 millimeters in diameter. It's pretty tight there. We'll go ahead and say 6.1. That's better. Go ahead and say Finish Sketch. And now we're going to make 2 extrusions. Now we're capturing this step profile here. So the first one, we'll grab the base and we're going to extrude it out 1.7 millimeters. Great. Now we want to reuse that sketch to get the second part of the step. So we'll go ahead and we'll make sketch 2 visible by right-clicking it and clicking Visibility. And then hitting the extrude button and just grabbing the center profile there. And this time we are going to make it 4.25 millimeters long. Great. So it looks somewhat like reality. We're doing pretty good. So next, what we want to capture are the nice smooth roundings here. Now, I'm not sure if you can see it in the model, but in the real object, but it's more of an ovular rounding around the edge of it. It's not quite a circular fillet like we used on the corners. So we're going to try and capture that. The first thing that we'll need is a plane that we can draw on. So there's a bit of a trick to this. We can come here and say plane, and we'll say plane normal to curve at a point. We'll click this edge here and this point here. And now we have a plane that's perpendicular to that edge. Extremely useful. So let's go ahead, we'll make start 2D sketch and come on this work plane here, and we'll slice the graphics using F7. Great. Okay, now I'll show you a trick. Say that we want to cut that edge so we can capture these corners easily. We can come here to project geometry and click project cut edges. Ooh, very good. But we're not going to be, oh, well, we are going to be using, never mind. We'll go ahead here and we're going to make 2 ovals. I want to use ovals to try and capture this corner here. So we'll say, let's go to circle, and underneath circle we'll pick ellipse. And we're going to draw 2 ellipses. Ellipses? Let me know how it's pronounced. Here we go. So we've got 2 ellipses. We haven't set any sizes, but we will set their positions and sizes shortly. We're going to add in a dimension that grabs the center of that ellipse and this edge here, and say that that's 7.5 from the edge, and same with the lower ellipse there, 7.5. Great. Next, we'll go ahead and we'll add in the tangential constraint with the upper ellipse. Oh no. There we go. Upper ellipse and the side ellipse. So add in tangential constraints with the lower ellipse as well. There we go. Wonderful, wonderful. Okay, and lastly, we just need these positions assigned. So we'll say 2.1, and this one also 2.1. Oh, 2.1. Lovely, great, wonderful, good. Okay, we'll say finish sketch. And let's go ahead. We are going to then cut away the ovular section that remains here. So we'll say sweep, and we'll grab selecting the solid, that solid there, and oops, we're not sweeping a solid. Don't do that. Click sweep. Make sure that this is unselected. We're selecting the profiles, so we'll click that profile there and that profile there. And for the path, we'll pick this edge around here. And behold, if we choose cut, ooh, we can cut away that material. So we'll click OK. Now we're done with this work plane. So we'll go ahead and we'll hide it by selecting it, right-clicking it, and unticking visibility. Okay, as we can see, this is floating around in space a little bit. Let's see if we can improve that. We'll go ahead and we'll make that sketch visible again. So we'll find sketch 2, right-click it, and click visibility. And now we're going to grab the inner and outer profile. And this time, we're going to extrude it into this direction. Now, we could just drag it along there like barbarians, but let's do the right thing. And we're going to say to next. And that way, it'll grab that profile and it'll extend it until the next surface it runs into. Beautiful. All right, we'll click OK. And we'll make that sketch invisible because we're done with it. Okay, so we've got one arm. We don't want to go through the process of making it on the other side because the key to efficiency is laziness. So let's go ahead, we're going to come to the origin, and we're going to make visible the YZ plane, so the one that bisects in this direction. So we'll find YZ, right-click it, and click Visibility. Great. Next, we're going to mirror these features. So we'll come along here, we'll say Mirror, and we're going to grab, let's see, we've got Extrusion 2, Extrusion 3, and Extrusion 4. And for the mirror plane, we'll click this one. And we'll click OK and hold our breath. Hey, looking pretty good. Okay, so we're done with this plane, so we'll hide it. Find the YZ plane and untick visibility. Okay, there's one more bit that we have to add, and there's a recess in this plastic frame that's holding the mirror onto there. So what we're going to do is we are going to cut that recess into it. We'll come here, say Start 2D Sketch, and pick this face here. And we'll say Project Geometry, and grab this entire face. Now, there's actually an opportunity here. We can see underneath where the frame is broken, we can actually see that it's not thin all the way through. There's just a lip there. So we're going to include that lip. We'll come along and in the same sketch, we'll come and add an offset, pick that sketch, and drag it in. And, oh, I don't know, let's measure it. We got our fearsome measuring tool. It is 9 millimeters. So we'll offset it inwards 9 millimeters. Great. Okay. We'll click Finish Sketch. And now we're going to make 2 cuts with this. The first cut is going to be the entire profile there. Well, the outer, there we go. This outer profile here. And it only goes in 1.5 millimeters. And now I'm going to make another cut using this one, but I don't want to repeat opening the tool. So I'll click this little plus. And we'll click this center profile. And this time we're going to cut it all the way through. We'll click Cut Boolean and click OK. Now we could mirror this cut here, but there's no real need. I'll show you another way. We'll expand our extrusion 5, which was that cut for that shoulder. Make the sketch visible. Oops. What am I doing? Sketch must be saved. Yes. Make the sketch visible. And then what we're going to do is make another extrusion. Select the same profile, but this time we're going to monkey around with the from field. So the from is where it's doing the adding or removing the material from the plane from which it starts the operation. We're going to change that plane by clicking on it and selecting the other side. Yeah, there we go. And now we can go ahead and add in our cut boolean and say 1.5 millimeters and change the direction. And yeah, there we go. Lovely, excellent, wonderful. Okay, next we'll make that sketch 4 visible. And that looks just about right. The only thing we'll need to do now is assign a material to it. So, I'm no polymer guy, so I think I'm going to say that's some kind of acrylic. Correct me if I'm wrong, please. We'll go ahead and say here, where are we? Polypropylene. Nope. Let's say, something PPS plastic, not transparent enough. We can do better. Polycarbonate clear. That's going to be clear. Looking pretty good. Very clear. I like it. Excellent. Okay, so we're going to save that first part. And we'll make it under here. And we'll call this one, we'll call this one the frame. No, we called it the, what do we call it? We called it the frame. We'll call it the frame. It's going to be the frame. Lovely. Great. Okay. We'll go off and we'll make a new part. Great. And we'll say standard. Okay. So we'll make a sketch on the XY plane. And we'll make a center point rectangle. And we'll say it's 94 wide. Was it 111? No, and 111 tall. I'm fairly certain that was correct. Was that correct? Let's find out. 111, 94. Yay! You can remember a thing. Great. Okay. We'll go ahead and we'll extrude it out. And from memory, it was 1.5 wide. Great. And what was the internal radius? It was 17.5. So we'll go ahead and we'll add in a 17.5 millimeter radius on each one of these. 17.5. Great. Looking good, looking good. Okay, so that's going to be glass with one side that's silvered. So we'll go ahead and we'll assign the material glass to this. Where is glass? It's somewhere. There we go. Glass. And that side's going to be silvered. So we'll come along here. We'll grab that guy. And we'll add the color picker. And for this one, we'll see if we can find something mirrored. Chrome polish, that'll do for our model. Great. Wonderful. Not that you can see it too much there, but that'll do. Now, the geometry of the glass panels macroscopically is the same. They're the same dimensions. This one's going to be slightly concave. Maybe if there's time at the end, we'll go ahead and we'll add in a nice concave thing, but probably not necessary. So we'll say mirror 1 flat. And then we're going to save a copy of this, which we'll come back to later. We'll call it mirror 2. And we'll say concave. Concave. Great. Okay. So we've got our base and we've got our mirror. We've got our frame. We've got our mirrors. The last thing to do, I'll just get rid of that last sketch, is to make the base. So that's this one. Now, there's a special trick to this because it's actually pre-cambered in so that when you slot it in, it's in tension. We're just going to model it in its upright position. All right, so we'll go ahead and we'll get started on that one too. Okay, the last part that we have to model is this space here. So we'll get to it by coming to File, New, Standard Millimeter Part. And we'll click Start a 2D Sketch, and let's make it on the XY plane. So we'll start off by making 3 lines. They're perpendicular to one another. You'll find that if you hover the line, a little icon will pop up that's inferring a perpendicular constraint. We'll make 3 perpendicular lines, and then we'll add in some constraints to give them some sanity. So we'll make sure that we add in an equal constraint between this arm and this arm, and we'll make a coincident constraint with the midpoint of this bottom line here and the origin. Great. We'll use the dimension tool to add in some dimensions. So we'll say that that's 117.5 millimeters wide and it's 82 tall. Wonderful. Okay, next what we're going to do is we are going to capture the curve here. So from measurements, it's 13.75 millimeters in radius. So we'll come along to fillet and we'll say 13.75 millimeters. Pick this line here and this line here. And the same again here and here. Wonderful. So we're nearly there. We'll go ahead and we'll click Offset. And we're going to prescribe the thickness of this part. Now for measurements again, it's 2.55 millimeters thick. Wonderful. And there we'll use little lines to close off the profile. In Inventor and Fusion, what's meant by a profile is a closed shape which we can use for extrusion. Okay, lovely. So we've got our closed profile. Let's go ahead and extrude it. And we're going to extrude it in both directions symmetrically for a total of 33.25 millimeters. Looking good. So we've pretty much got that, but without these bits cut out. Okay, so next we'll come along and we'll make a 2D sketch on this arm here. Looking good. And we're going to draw some shapes. So let's go ahead. We're going to draw one circle that's going to represent this top curve here. Now, from our measurements, we can see that it's 15 millimeters. Now, we're going to use our constraints. We're going to make sure that it's tangential to the top there and also vertically aligned. So we're going to click the vertical constraint, click the middle of that circle, and then the middle of that line there. Great. Now, from our last part, we made a little arm that slots into that hole. We're not going to worry too much about tolerances here, but we'll go ahead and we'll put the 6.15 diameter. I think that's it from memory. We can always change it later. And then we'll go ahead and we're going to complete this profile. Now this is going to have some artistry about it, but what of it? That's okay. We'll go ahead and we'll make an arm and we'll draw a straight arm there. If you're wondering how I drew a straight arm that was tangential automatically from the circle, you can click on the circle and drag the tool with the line tool selected. And it will make a line that's tangential to that circle. A useful little trick. Great. Okay, so let's go ahead and we are going to draw 2 arcs. One that happens to be tangential to this line here, and oops, there we go. And one that happens to be tangential there. We'll do the same on the other side. Don't worry about the proportions just yet. So one arc like that, and another arc like that. Great. And now we can go ahead and add in our constraints and dimensions. So that these constraints, these arcs are all going to be tangential with one another and with the walls. Great. So we're just adding in tangential constraints. And oh, this one's gone rogue. We'll go ahead and connect it using a coincident constraint. Grab the end of that arc and the side here. And it's become really little there. Go ahead and add in a tangential constraint between that last arc and that side. Wonderful. Okay, so at the moment, they're all different sizes. That's fine. We're going to go ahead and we're going to add in some equal constraints between these 2 arcs here and these 2 arcs here. We'll do the same, add in an equals constraint with the straight portions as well. And we're going to give sizes to those arcs. So we'll say that that's 38 millimeters and this bottom one's also 38 millimeters. Great. And they're not, while they're all equal, they're not symmetrical. So what we're going to do is we are going to prescribe a distance from here to here. We'll say that that's 32 millimeters. And it's not fully constrained yet, as we can see. So how can we get this fully constrained? What constraints are missing? We've got them equals. We could put in an angle, but I'm sure that it'd be nicer if we just come ahead. Yes, we'll add in a horizontal constraint so that these arcs are both on the same level. And now we've got, yes, good. We've got symmetry, but it's not quite fully constrained yet because it can still move around. So we'll go ahead and we are going to add a coincident constraint, end of the arc there. There we go. We can do better. We'll go ahead and we'll add in a fixed distance here. There we go, 10 millimeters. It's not going to be perfect. I'd have to measure it all perfectly, but it's up to you if you want to replicate it. We'll go ahead and click Finish Sketch. And now we'll grab our closed profiles and we'll extrude them. So 1, 2, 3. And we're going to extrude them to the other side as a cut. Lovely. I think that looks pretty good. In fact, better than the original. Okay, great. Let's go ahead and we'll assign a material. So come here, generic, glass. No, not glass, acrylic. We don't want another smashing accident, no. We'll come along here, polycarbonate clear. Lovely. So we'll go ahead and we'll save that and we'll call it the base. Okay. Lovely. The last part is actually making the assembly, so this part. So minimize that one. It's cheating to use it. Go ahead and we'll make a new standard millimeter assembly. And we'll start off by placing down the base. So we'll say place, and we'll go to our part base. And I'll show you a trick. We want to ground it at the origin. So to do that, we can right click and say place grounded at origin. Fantastic. Great. Okay, next what we'll do is we'll come to place and we'll choose our frame. And we're just going to place it arbitrarily in space. So when something is grounded, it can't move. But when something isn't grounded, you're free to translate it around. Now, we're going to use constraints to get this to sit into this little socket here. So we'll come to constraint, click this cylinder here, and this cylinder here, and click apply. And we can see that it's free to translate and free to rotate. So what we'll need to do is we're going to need to fix it in its translation. Now we could use joints, but if this was designed properly, this width, 117.5, we'll use the measure tool, M, to measure 117.5. Lovely, we did a good job. So what we're going to do is we're going to make a constraint. And what we will do is we will constrain, and we're going to make flush the end of this barrel here with the end of this face here. Great, lovely, good. Okay, so cool, we've got a rotation there. And now we'll go ahead and put in our 2 bits of glass. So we'll say mirror 1 and mirror 2. Great. All right, so we'll go ahead. I can't actually tell which side is silver, but I suppose it doesn't really matter. We'll constrain that and place it in there. And we'll grab one of these faces and constrain it to the wall there. Looking good, almost done. Oh no. And constrain, come on. It wants to play with me. Constrain that face there with that face there. And looking good. Oh, it's flipped upside down. Yeah, okay. All right, and now we have to do the same to the other side. So we'll say constrain. Good. Constrain. Also good. And lastly, one more to stop it. Oh wait, no, did we already do it? 1, 2, it should be, I'll just ground that one to keep it in place for a moment. Yeah, here we go. We'll constrain that face with that lip there. And now we've got our completed mirror. Lovely, excellent. I'll just unground that so it can move around. Wonderful. I think it looks pretty similar to the original. Well, the polycarbonate is a bit more clear. Mine's gotten a bit foggy from use in the shower. But I think that it looks pretty similar. What do you think? Excellent. Okay, so next what we're going to do is redo this in Fusion 360. I'll see you there. Shooting the Fusion video, I realized I'd forgotten the feed on this thing. So let's go ahead and add them now. So here we've got the assembly that we left off from last time. We're going to go ahead and we're going to find the base there. And we don't have to open up the file by itself. We can just right click it here and say open. And now we're going to go ahead and add in those little feet at the bottom there. So we'll go sketch, and we're going to make a sketch at the origin plane. There we go, the one that bisects it there. And we'll go ahead, we'll make two little rectangles, one here and one here. And we'll go and add in some equals constraints. Yeah, looking good, looking good, looking good. Dimension 1.5 tall and 6.5 wide. Great. Extrude them both out in symmetrically for a total of 87 millimeters. Great. And we'll finish it off with some sweet chamfers. So we'll come along here, chamfer, and click these edges. 1, 2, I'm losing control. 1, 2, and distance 1.5. Hey! Okay, let's see, double click, there we go. Now it's got feet. And if we save it there, close it down, we should have that reflected in the assembly. Wonderful. Okay, tune in next time and we'll have a look at how to make a drawing from this guy. Okay, have a good one. Thanks. Bye.